Well, welcome back. Our topic today is the mean value theorem. So go ahead and copy this sketch down that I have on the board here, and we'll get back in 2 seconds. So again, copy that sketch down exactly how you see it. So in order to apply the mean value theorem, two things have to be true here. First of all, f of x has to be a continuous function, and take note that it's on the closed interval a to b. So what am I saying by that? Well, you have to get from point A to point B, basically without picking up your pen or pencil. So I'm saying there are no holes, okay, or vertical asymptotes. I have to get from point A to point B without picking up my pencil. And statement 2 here says f of x has to be differentiable on the open interval a to b. Watch the difference between the two. Differentiable, I'm saying that there's no corners or cusps. Basically, I shouldn't have an absolute value curve. If those two things hold true, then, and here's the sentence we're going to use, there exists a C value, I'm going to put it in quotes there, in between A and B, okay, so notice I have that open interval again, such that, and here's the mean value theorem, f prime of C equals f of B minus f of A all over B minus A. And hopefully that theorem sounds familiar to you. And this is basically the sentence you're going to use every time. Then there exists a C in A and B such that this is true. So again, what am I trying to tell you? Well, let's break this down a little further and talk about what these two functions mean. This should look very familiar to you. This is just the average rate of change. And I'm going to ask you to name this side of the equation in several different ways. So one of them is the average rate of change. Notice at this side, I'm finding the derivative at an instant in time. So this is called the instantaneous rate of change. So again, I'm comparing the average rate of change to the instantaneous rate of change. Another way to think of this, which again you'll be asked on the quizzes from now on, at least 3 different ways here, is that when I find the slope between 2 points, and again it's 2 points because I'm using A and B, that is called not only the average rate of change, but that is the slope, and again between 2 points would be of a secant line. Versus if I find the slope at 1 point in time, that is now your tangent line. So I'm saying these things are equal. The instantaneous rate of change equals the average rate of change, and sometimes they'll word it like that without saying mean value, and you'll have to pick out mean value from that. Or the tangent line equals the secant line. Okay, the slope of the tangent equals the slope of the secant. So let's go back to our picture here. Basically, we already have drawn in for us, between 2 points would be my secant line, and the mean value theorem says as long as this function is continuous on the closed interval and differentiable on the open interval, then there is this value c, such that you can draw a tangent line that is equal to it. And by equal, we mean parallel. So I would definitely say I can draw a tangent line right here that is parallel to this secant line. So this value that I found this at is what we'll call C. And that's all the mean values theorem is saying, is that the average rate of change equals the instantaneous rate of change, or the slope of the secant equals the slope of the tangent. So example 1 says determine if the mean value theorem and or Rolle's theorem applies to the function in the given intervals. If either applies, find the values of C that are guaranteed by the theorem. So we haven't reviewed Rolle's. I don't want you to worry about that at the moment, and we'll just focus on the mean value theorem. So before you even begin, you have to first ask yourself 2 things. Is your function continuous on the closed interval and differentiable on the open interval? Okay, those 2 things have to go on first before you can answer the question. So to determine if I'm continuous, I'm basically just asking myself, is there any number for x that I can't use? Is there any number you can't take the square root of? Well, certainly. If the junk under that radical is greater than or equal to 0, I'm in good shape, because I can use 0 as an answer. So basically, everything under there has to be greater than or equal to 1. Now, apply that to your domain here. That's exactly what we have, any number bigger than 1. So check, I'm definitely continuous. Am I differentiable? Well, obviously differentiable means to take the derivative. So f prime of x is equal to 1/2 x minus 1 to the negative 1/2 times 1. So I could say that's 1 over 2 square root of x minus 1. And again, I'm going to ask myself, what's the domain here? Are there any numbers I can't use? Well, the only thing I have to worry about is the denominator. And I'm going to set that junk under there. And that has to be greater than 0 because it's a fraction. And I certainly can't have 0 on the bottom. So I know x has to be greater than 1. And again, that's a check because that's in my domain, 1 to 5 here. So the function is continuous and differentiable. Therefore, all I want to say is that the MVT applies, since those two things are true. Now, let's go ahead further and apply the mean value theorem. Well, all the mean value theorem said was f prime of c equals f of b minus f of a all over b minus a. Now, we already found f prime of c right here, and we'll just plug in c. So 1 over 2 square root of c minus 1 equals, and now my function was just f of 5 minus f of 1 all over 5 minus 1. So as I continue to clean it up, if I evaluate f of 5, I believe I get 6 minus 4. So I've got 1 over 2 square root of c minus 1 equals 2/4 reduced to 1/2. I'm going to go ahead quick cross multiply, solve for c. So 2 equals 2 square root of c minus 1, divide out the 2. And I get c equals 2. Now just make sure that this answer falls between your interval, which was 1 to 5. And there you go. We found the one place where you can draw a tangent line that is parallel to the secant line, and that is when c equals 2. Let's try another one. All right, question 2. So again, I want to apply the mean value theorem if possible. So the two things I have to check for is f of x continuous on the closed interval and differentiable on the open interval. All right, so let's start with the first function. Since I don't have to worry about any fractions, I basically just ask myself, is there any number in the world I can't plug in there? Is there anybody that you can't take the 5th root of? Well, certainly no. So I would say this function is continuous. All right, now let's try differentiable. Obviously, again, take the derivative for differentiable. So f prime of x equals 6/5 x to the negative 2/5. And I think it's a lot easier if you rewrite it. Got 6/5, the 5th root of x squared. Now, because you have a fraction, you have a domain restriction. What is the only number that you can't have here? Well, hopefully you're saying x cannot equal 0. Now, does that 0 fall within your open interval? And it definitely does. Therefore, the MVT does not apply. Okay? If I'm not differentiable on that open interval, which I'm not at 0, mean value theorem doesn't apply. All right, so let's attack some AP free response style type questions. Example 3. G of x is a differentiable function. Okay, so we already know our function is differentiable, and let's underline that, and that implies continuous. If you are differentiable, you have to be continuous. All right, so there's our table, and it says, must there exist a c between 10 and 20, so I'm using from here to here, such that you have a slope of 0, and justify your answer. Alright, well if I have a slope of 0, I basically have to say to myself, I need to pick 2 points where when I use the slope formula, f of b minus f of a, all over b minus a, I get an answer of 0. So is it possible, if you just stare at those points, is it possible to come up with 2 points? Well, think about it. if you use 10 and 12 here, change in y over change in x. No, that's not 0. If you did these two, change in y is 1. That's not 0. Basically, if I want my answer to be 0, I need 0 over any number. So I want my two y values to turn out to be 0. Hopefully you're recognizing these 2 points. So, how do we answer this question? Well, first of all, we're definitely going to say yes. Okay, must there be a value? Yes. Since g of 10 equals 23 and g of 18 equals 23, then there exists a c value, just like they asked for, now remember it has to be in the open interval, 10 to 20, such that, and now just show that math. G of 18 minus g of 10 all over 18 minus 10 equals 0. And there you go, that's all they're looking for. Nothing too mind-blowing. We answer the question, we stated our values, and then we use this nice little sentence. Then there exists a c in the open interval such that that math is true. Alright, let's answer part B as well. It says, must there exist a c value between 10 and 14? So I'm going to block it off. We are strictly looking between 10 and 14. So just in that section, such that you have a slope of 0. Well, again, if you did your change in y over change in x between any of those points, are they ever going to equal 0? Hopefully you're saying no. So again, my answer right off the bat would be no. And then of course it says justify. I would say there are no values between 10 and 14 such that I'm just going to use g of, I guess, c1 minus g of c2 all over c1 minus c2 equals 0. There are no place where I could do the slope between 2 points, and again, I just call them c1 and c2. Feel free to call them whatever you want, such that you get a slope of 0. Alright, example 4. Given that v of t is differentiable, so again, I'm going to say to myself that implies continuous. A, must there exist a c? So again, that's my hint that they're talking about the mean value. Between 20 and 44, so I'm just going to break it up, such that the slope equals 1/3. Well, you only have 2 points to play with here, so I'm going to say v of 44 minus v of 20 all over 44 minus 20 equals 1/3. And my goal is either to show that it does or that it doesn't. So 18 minus 8 gets me an answer of 10 over 22. And would you say 22 is equal to 1/3? Hopefully not. So again, no, since that's not true. And letter B, same idea here. Must there exist a c value between 44 and 80, such that v prime of c equals negative 1/6? And I would say v of 80 minus v of 44 all over 80 minus 44 equals negative 1/6. And we'll just verify the math here. That's going to get me 12 minus 18 all over 36, which is negative 6 over 36, which is negative 1/6, equals negative 1/6. So I would definitely say yes. Okay, and we're going to sum this up with the mean value theorem, of course. Since v of 80 minus v of 44 all over 80 minus 44 equals negative 1/6, there is at least one c such that d prime of c equals negative 1/6 by the mean value theorem. All right, so let's go ahead and focus on Rolle's theorem right here. Now, in case you forget it, it's actually not going to be the worst thing ever, as long as you understand that it's just a special case of the mean value theorem. So if you see the word Rolle's and you totally get stumped, just remember it's the mean value theorem and you're in great shape. Now, if you can remember Rolle's, there's one extra characteristic here you'll note about it. So it's very similar to mean value theorem. Like we said, it's a special case. Your function still has to be continuous on the closed and differentiable on the open. But here's that third characteristic. If f of a equals f of b, meaning they're the same height, f of a is the same as f of b, that's a special case, because what do you notice about the slope if a and b are equal to each other? Hopefully you're saying that you have a slope of 0. So basically, half the problem's done for you if you catch Rolle's theorem. And what do I mean by half the problem? Well, we already know that one side of the mean value theorem, so f prime of c equals f of b minus f of a all over b minus a. If those 2 points are equal, just like we drew here, we know that this already has a slope of 0. So you basically don't have to waste time plugging your numbers in. Like I said, if you forget, the world's not over. All you're going to do is plug your numbers in, and you're going to get 0 as an answer. And then, of course, you just set that equal to the derivative and solve for c. So let's go ahead and apply one problem to this. So here's our last question for the night. Find all values of c. So again, that's your hint mean value, or in this case, they say Rolle's, that satisfy Rolle's theorem for this function on the closed interval 0 to 1. Now remember, because it's a case of the mean value theorem, you still have to check for two things. First, is the function continuous on the closed interval? Okay, so I'm checking for continuity on the closed interval. And all I'm saying to myself, is there any number in the world that I cannot plug in? Is there a restriction of the domain? And hopefully you're saying no. Really, I only need to worry about fractions and even-powered roots. I can take the cubed root of any number I want, therefore I'm good to go. So, is the function continuous? Check. Second, is the function differentiable, this time on the open interval 0 to 1? Well, how do I know? I'll just quickly take its derivative. 2/3 x to the negative 1/3 minus 1/3 x to the negative 2/3. And rewrite it for yourself. Makes it a lot nicer. And again, you're asking yourself, is there a domain restriction? Is there a number you're not allowed to use? Well, because you have a fraction, that answer is yes, right, immediately. And just look under there. What's the only number you can't put in there for x? Hopefully you're saying x cannot equal 0. Now, look at that domain. Remember, it's differentiable on the open interval. Even though 0 is an endpoint, it's open, so it does not count. So this is going to check as well. The function is differentiable on the open interval. Okay, so stress that to yourself. Continuous on the closed, differentiable on the open. All right, now I've got to find that value for c. So I'm going to take my f prime of c, which I really just found here. So 2/3 cubed root of, I'm going to use c, minus 1/3 cubed root of c squared. If you want to call it x, that's fine too. Equals, and here's that special part about Rolle's, we already know this side is equal to 0. Okay, so now I just have to solve my function, and I'm just going to bring this to the other side. Obviously, I just added it over. And at this point, I'm going to cross multiply. So I've got 6 cubed root of c squared equals 3 cubed root of c. And before I do anything fancy, I'm going to divide that 3 over. So I actually have 2 cubed root of c squared equals the cubed root of c. If I don't like cubed roots, I can simply do what to both sides? Hopefully you're saying cube them. That eliminates that, and I've got c. Just make sure you cube everything in here. That 2 should turn into an 8, and then those cancel, c squared. Now I want to stress, you cannot divide by c. That kills out an actual answer. All you have to do is set your function equal to 0. I can factor out a c so I don't lose that answer, and solve. So I actually should get two solutions, c equals 0 and c equals 1/8. Now, you're not done there, and this is where they love to get you on the multiple choice. Remember, your answer, if you look back on that first page, our answer has to fall in between. Okay, star that, underline it. You have to fall in between those bounds that we had, which were 0 to 1. Okay, you're in between the closed interval. So let's check our first point. Does 0 fall in between 0 and 1? Well, certainly no, it is one of those. Does 1/8 fall in between 0 and 1? Yes, it does. So the only answer I have is that c equals 1/8. Well, there you have it. If anything went too fast for you, obviously it's in your hands. Pause it, rewind it, replay it, do what you need to do to get this down today. Have a great night.